So this is more Maple. And the first thing we're going to learn are some commands about polynomials. So polynomial factoring and expansions. So polynomial is an expression that looks like, let's say, 7 times x cubed minus 29 times x squared plus 31. That's a polynomial. And in high school and in pre-calculus, you learn a lot about factoring polynomials. So let's say we have a simple polynomial like x squared minus 1, and you know you can factor it because that you learned and use that in calculus all the time, for example. But the simple command to factor a polynomial is just the word factor. And in parentheses, you put the polynomial you want to factor, and there it is. If you have the polynomial even in 2 variables, say x cubed minus y cubed, that's factored. If you have something that's not quite so obvious, maybe x to the 12th minus y to the 6th, and you want to factor it, wow. Might be hard to do that by hand, but that's the factorization. So that's a simple command for factoring a polynomial. Now, sometimes you have 2 polynomials, let's say, well, x to the 3rd plus 11 x squared minus 9x minus 21. And you have another polynomial, 7x to the 4th. I like to put in the time signs. Minus 13 x squared plus x minus 9. And if I want to multiply them, I put this dot in there. And the command to multiply them, I have to, if I just leave it like that, it's just the product of the 2 polynomials. The command to multiply is really, or to expand, is expand. If I write expand, and I put this all in parentheses, that's what it is. Kind of a mess to do by hand, but Maple does it. And suppose we want to check by factoring. Let's factor this. So let's just give the command factor. I'll put a parenthesis, a percent sign. That means factor the last thing I calculated. And I got back to this. That's pretty good. Let's look at another example. Suppose I want to factor x squared minus y to the 4th times x to the 6th plus y to the 9th. Actually, before I factor it, let me expand that. It's more interesting. Oops, missing operator. I forgot the parenthesis here. Okay. Yes. What's inside the expand? Let me put in some extra spaces. This is what I'm going to expand, and I have to have that inside parentheses. So if you multiply it out, that's what you get. And suppose I want to factor that and see what happens. Ooh. You might say, well, I get this when I multiplied these two, I got this polynomial. But when I factor this polynomial, I didn't get back this expression. I got something like this. And the reason is that Maple is thorough. When it factors this as much as possible. So these two polynomials here, each of these could have been factored. So when I factor this, I don't get this expression. I get everything in here factored. So x squared minus y to the fourth is x squared plus y and minus x squared, sorry, y squared plus x, and or sort of x minus y squared and x plus y squared. These two factors, if you multiply them, would give you this. So here, the takeaway from all this, though, is these two basic commands, which I will. Oops, that's not what I wanted. So I'm introducing the following two new Maple commands: factor and expand. Now, you might say, what about factoring a number? So, you can also factor integers. So that means if you take, for example, the number 6, when you factor it, you get 2 times 3. And so suppose I want to factor an integer using Maple. So if I write factor and then I just put 6 inside, it gives me 6. It didn't factor the integer. And that's because factor is a command for a polynomial. Factor the polynomial 6, and that's 6. There's a separate command for factoring an integer. So here's another new Maple command. It is ifactor. The I stands for integer. So if I say I factor 6, those are the factors. If I take a big number and I want to factor it, that'd be hard to factor by hand, but miraculously Maple can do it. The prime factors of this number, the minimal components of this number is 2 times 7 times 59 times 97 times 109. And these are factors that, these are prime, these can't be broken down anymore. If I do this, you multiply it back and you see you get back the number you started with. So this is the third, maybe I should number these because they're the first new Maple command is factor. The second is expand. And the third today is ifactor. All right. Now this is a new, another command, which is very important because this is what you spend a lot of time doing in calculus. you compute limits. So, oops. Let me put the sharp sign. This tells Maple this is not a Maple command. This is just a comment, a statement that you're writing down. So if I want to find the sequence, if I have the sequence that say 1 over n, and I want to find the limit as n goes to infinity, the command would be limit and say 1 over n, comma, and n equals infinity. And you get 0. Now, there are some commands in Maple that can be written with a capital and have a different effect on your output. So if I were to write this statement with a capital L and not a lowercase l, what I get is the statement of the problem. This means find the limit as n goes to infinity of 1 over n. And what is extremely useful is to be able to put these two things together. So if I write limit with a capital L equals limit with a lowercase l, I get on the left-hand side the statement of the problem, and on the right-hand side, the answer. So for example, if I had sine of x over x, as x goes to infinity, I get this fundamental theorem from Calculus 1. And if you had sine of 3 times x, for example, over 2 times x, oops, sorry. This is a correct statement, but the limit in calculus that I'm interested in is because as x goes to infinity, sine of x is between -1 and 1, but the denominator is going to infinity, so the limit is 0. So the limit in calculus that's fundamental is the limit of sine x over x as x goes to 0. And that limit is 1. And if I take sine 3x over 2x as x goes to 0, that limit is 3/2. Doesn't matter what variable you use, but suppose you have the limit of log of x over x as x goes to infinity. What is that limit? That limit is 0. Suppose I have a limit of x cubed plus x squared minus 1 divided by 7x cubed plus 20 times x minus 15. Huh. So that limit of this rational function is a 7th. If I made this x to the 4th, so this is a 4th degree polynomial over a cubic, that limit's infinity. If I made this x to the 4th, that limit is 0. And these three limits show you an important fact from calculus. If you have a rational function, that means a polynomial divided by another polynomial. If the polynomials have the same degree, in this case, they both have degree 3, the limit as x goes to infinity is just the ratio of the coefficients of the highest terms. This is 1 times x cubed, 7 times x cubed. So the limit is 1/7. Maybe I can make it clearer if I made this 2. The limit would be 2/7, the ratio of the coefficients of the leading terms. When you have a rational function where the polynomial has degree bigger than the denominator, the numerator has degree bigger than the denominator, that limit's always infinity. If you have a rational function where the degree of the numerator is strictly less than the degree of the denominator, that limit is always 0. So this is an important observation in calculus, and we can see it computed explicitly using Maple. Let's go back to solving equations. So if we want to solve the equation, for example, x cubed minus 5 times x plus 11 equals 0, there are two commands in Maple. One is solve. Now I'll solve for x. And I get something, well, effectively incomprehensible. This is kind of, and that's because there's not an easy way to give an explicit solution of this. So if you want a solution, a numerical solution as a decimal, you use the command fsolve. And it looks like there's one solution. If you want to check graphically, you can plot the function that's what the graph looks like. Looks like it crosses the x-axis here, close to 3, like mine, close to -3, which is this. Here it looks like it just misses. If I want to make sure that it doesn't cross the x-axis anywhere else, I can just graph it, say, maybe from -5 to 5. So If you don't give a range of value for x in a plot, the default is minus 10 to 10. If I give a range, say x equals minus 5, 2 dots, 5. So now we really see the curve. That's what it looks like. And this is the one place where the graph crosses the x-axis, which means there's exactly one solution to this. Now, it's possible to plot 2 or more curves on the same graph. And if you want to do that, you put the curves inside curly brackets. So maybe we have the parabola x squared minus 3. And we have another parabola. Well, let's make it, I don't know, 5 minus 2 times x minus x squared. So I put these in curly brackets, comma x. So you see the parabola going up, that's in red. The second parabola going down is in blue. So that's kind of pretty. Let me just look at this from minus 5 to 5. And you can see these parabolas cross at 2 points. And you might want to find the coordinates of the points of intersection. So the x coordinates of the points, that's when x squared minus 3 equals 5 minus 2x minus x squared. So I can solve the equation x squared minus 3 equals 5 minus 2x minus x squared. If I solve that for x, I get 2 numbers, this point and this point. If I want it as a decimal, I can use fsolve. And this says that at the point where the points where these parabolas cross, the x coordinates of the point of intersection are 1.56 something and minus 2.56. If you want to find the y coordinate at this point, well, one thing you could do is to blow up the graph at this point. Let's do that. So this is a kind of magnification process. This is around 1.56. So maybe I'll graph this from 1.5 to 1.6. And this is the point where the parabolas are intersecting. And the y coordinate, something like, well, somewhere in this range. Let me blow this up more, maybe 1.55, 1.56. Oops, too much, 1.57. So this x coordinate where they intersect, which is about 1.561. Really blow this up. So here's the x coordinate, and you can see the y coordinate is about, let me just write this down. So the y coordinate of the point of intersection is about minus 0.561. So we can see that by magnifying the curve at this point. And at the second point of intersection, we can magnify the curve and find the y coordinate here. So there's one more Maple command I want to introduce. This will be number 6. And this is what is called the assignment operator. So in the assignment operator, it's a colon followed by an equal sign. That's the symbol. So suppose I want to give the x the value 3. So I would say x colon equals 3. And now, whenever Maple sees an x, it replaces it with the value 3. So x squared is 9. 4x is 12. I have assigned to the variable x the value 3. This is extremely useful. So this is a very important Maple command, the assignment operator. And I can use it in clever ways. So for example, oh, now here's a problem. Yep. If I wanted to solve this equation now, I would get an error. And the reason there's an error is that in this equation, x, I want x to be a variable, but I already said to Maple, x is 3. So every time Maple sees x, it puts in 3. So I need to erase this from the memory of the computer. One way to erase everything that you've stored in the memory of the computer in your worksheet is to go to this command bar here, and where you have this round symbol, you click on that, and now x is no longer 3. Oops, there should be a lowercase x. X is x. It's x again. So I erase this from the memory of the computer. And now when I solve this equation, I get the solution. Suppose I want a way to remember these things. I can do the following. I can say let A be assigned. So A is assigned whatever this is. And it turns out there are 2 numbers here. So the computer stores them as A square brackets 1. That's the first number. Oops. Let's see. Yeah. So here's A. A1 is the first number, and A2 is the second number. So this 1.56, that's the coordinate here. In the equation x squared minus 3, if I let x be equal to this A2, x squared minus 3, that's exactly the y coordinate of this point. So there's a lot that I just did in this lesson, and it's really important to spend some time going over these commands and learning them and doing examples of your own and doing the homework problems. So that is the end of this lesson.